Here. Thanks for having me. This is going to be part presentation, but also interactive. So I want to give an overview of Pandas, just kind of speak to my background. I've been actually working in reporting and analytics for a long time, and over the past couple of years, Python has really made its way into reporting and analytics as kind of the de facto language in a lot of cases. And part of the popularity of that is actually due to Pandas. If you aren't familiar with it, it's a good data analysis toolkit that has good integrations with things like scikit-learn if you're doing machine learning, or just a bunch of other tools that are out there. So actually, even over the past 6 months, I've been a pretty active contributor to it. I don't know everything about it, but I've used it enough in my past experience and contributed to kind of build an expertise. So I just want to give you a quick overview of how to get up and running with it as fast as possible. And obviously, if you have any questions, feel free to ask at any point in time. All right. So let me zoom in a little bit there. So real quick, what we will do in the next 5 minutes, hopefully not go too far beyond that, we're going to set up a development environment, get Pandas installed, and actually use it for the first time, explain to you some of the core concepts. What you need for this is really just the Unix shell. That's it. You can do IDEs and other things if you want to. I kind of am a minimalist and just like using a shell on a notepad, a little bit old school like that. But if you want to do IDEs and other tools, welcome to do that in your own time. Real quick for PC users, I've not used a PC in almost a decade, so there are some things you would have to do different than what I'm doing in the presentation here. I do know that you can use PowerShell and command prompt to set up your environment. The commands will be different than what we go through. There's always the option for getting Unix shell installed on a PC as well. I just can't answer those questions for you, so apologies in advance on that. All right, so a development environment. If you aren't too familiar with it, what we want to do is set up a virtual environment first for Python. One of the tools that Pandas comes packaged with very closely is called Conda. So if you've used pip or virtualenv or venv or pym in the past, they all kind of do different things. What Conda does is within one tool, it allows you to set up virtual environments and also use it as a package manager, which is really nice when setting these things up. Again, you could use all the other tools, but Conda is just kind of the easiest one. So let's get things started off. I put the code here in the slides, and we can send these out afterwards. Basically, simple Unix stuff right here. All we're going to do is go to the downloads. I'm going to download the file that we need to install. I have in bold there. You can see this is for Mac OS X, so if you're using Linux or a different architecture, you should change that. But we have that downloaded on the terminal. How do you do it? Learn something new every day. We'll make that executable really quick, and then we'll just install it. Okay, so simple installation process. You just say yes to everything, accept all the defaults, and you're good to go at that point. Obviously, you can change the location of where this gets installed to if you want. By default, though, it's in your user space, which is really nice. You don't need any super user or admin access to install and manage your Python versions, which is, if you've run into that limitation before, it's really nice to have a tool that just takes care of that for you. So this is Conda, again, going through the process now. It's setting up a default Python environment for us that's separate from Python that comes installed on the OS X system. It will update your path and everything for you, so you don't need to do anything else. It just did update my path, but I'm going to close and reopen terminal so that those changes are reflected. Okay, next step is, at this point, Python is installed, Conda is installed, we have a virtual environment set up. It comes with a root environment, but it's typically a good idea to create, again, a separate environment, even outside of the root, that you can use and manage your packages in. So we will do that really quick with this command. I'm going to create a virtual environment called Pandas Demo. By default, it's just going to use the latest version of Python, 3.6.4. Once that finishes, and whoops, my mistake. Yes. and it tells you what to do next. So after you install a virtual environment, you activate it, and that's it. So again, this is not really like Pandas specific, but if you've never really used a virtual environment before, it's really good to set it up in the up front. You may not even realize why it's a good idea until you use it for a while, but just kind of trust me that having a virtual environment and a tool to manage that for you is like a really good idea. All right, so that is set up and activated. Now we're just going to install Pandas straight from the command line. It's easy with Conda install Pandas. It grabs for you all the dependencies. The biggest dependency that Pandas comes with is NumPy. So if you use NumPy, again, it just kind of comes with that. Just because a lot of the internals of Pandas are implemented in NumPy, it gives you very good performance that's optimized kind of at the C level a lot of times too. While this is downloading and installing, just some other packages that I can't cover in 5 minutes, but you may want to think about. SciPy and scikit-learn for machine learning, if that's kind of your focus area. There are a lot of integrations there between Pandas and those packages. Matplotlib and Seaborn, if you want to generate plots out of Pandas, you can do it directly in a pretty easy-to-use syntax. IPython is a good alternative to doing Python interactively. It's more of a robust interactive session. And then Jupyter, if you're not familiar with it, is also a good tool to kind of learn Python. You can set up notebooks and click buttons and have it go through the code interactively, show you the input and output of it in a very, basically in your web browser. So you'll see a lot of those floating around the internet nowadays to teach you Python and especially Pandas. So while that's downloading, should be installed very shortly. We can move on to just major concepts. So speaking specific to Pandas, there's a lot that the library does. I'd say if you're just really trying to get started, there are 3 things you should know about. There's a data frame, there's a series, and there's kind of a group by object. If you have worked with Excel or any kind of tabular data before, a data frame and a series will be like very natural to you. A data frame essentially is an Excel sheet, and a series is a column in Excel. And a group by is, if you've done SQL before, it's kind of the same thing as a group by in SQL. It's a way to aggregate your data and perform calculations against it when you want to kind of reshape your data into a different format. So with that, the tool is installed. Gone over all the concepts here. We will get things started with a very quick demo. So firing up Python, what you'll see with almost all Pandas code is import Pandas as PD. That's just kind of a convention, so you don't have to namespace everything as Pandas. And we'll also import NumPy, which you don't need to do every time, but just for this example, it'll help things become clearer. Okay, so let's talk about a series real quick because that's the easiest out of all the concepts on that previous slide. Really, let's say we wanted to generate 100 million random numbers. I will do that right now with a mean of 1, a standard deviation of 0.5, and that is 100 million right there. So this hopefully won't take too long. There we go. We have a series with 100 million random numbers in it. And what Pandas kind of does is give you, again, a very easy way of interacting and analyzing your data. So describe is a very easy method to start with. It gives you count, mean, standard deviation, the min, and kind of the quartiles of your data. So again, over 100 million rows of data, I told it that the mean was going to be 1 and the standard deviation of 0.5. So you see that reflected in the numbers here with a slight rounding error, just the way that computers work. But, as far as cranking out calculations against 100 million records, if you try to do that in Excel, you'd probably have to buy 100 different computers and chain them all together some way. Not very fun, but here we can do it in a couple seconds realistically with Pandas. So once you move beyond a series, the next thing to consider is a data frame. So again, a data frame is really similar to if a series is a column in Excel speak, a data frame is an entire sheet. So what we'll do here is we will generate a data frame that has two columns. I'll call one key, and in the key column, we will do 500,000 foo records and 1 million bar records. And then for the values column, what we will do is just take the numbers 0 to 1.5 million. Okay, so that's our data frame right there. A couple easy things you could do. Just owing itself to a Unix background. Head will give you the first 5 rows of data. You can change that parameter and give more than 5 back if you wanted to. Tail 10 will give you the last 10 rows. And what you see here is really all the way on the left is an index that was auto-generated. Again, that's just incremental from 0 to the size of your data frame. Key is the column that I gave the values foo and bar in, and values are the numbers 0 to 1.5 million, essentially. So you can inspect your data frame. You can look at the columns, again, key and values, so it's not quite as visual as Excel, but it's also not that conceptually different. And it's really, again, just series, but you're really chaining together a lot of series into one data frame if you think about it that way. Group by is where things get really interesting. So a lot of times when you have a data frame with data, and again, if you've done any kind of SQL reporting before, this should kind of come naturally. We may want to know things like what's the average value for foo and bar, or the maximum or the minimum, things like that. This is where group by comes into play. So the syntax for that is very easy. I already have a data frame, so I'm going to take that and say I want to group by key. So in my key column, again, I only had foo and bar as the 2 values there. So when I say group by key, it's going to look at the record foo and perform, basically aggregation of all the values for that, and then same thing for bar separately. So you can do things like the minimum for each group, and you'll see it returns a data frame. So the minimum of foo is 0, bar is 500,000. Similarly, the maximum is there. If you wanted to, you could take the 327th value within each of those. I don't know why you would do that, but if you wanted to, you could. Some standard deviation, anything mathematical that you can think of is really available to you as an aggregation function. You can pass it lambda functions as well, although I'll caution that if you do anonymous functions against large data frames, you're really going to have slow performance. But if you use, especially if you're dealing with numerical data and performing standard calculations, performance is really unmatched by anything else that you'll see that you can run on a PC, essentially. To the question before, I know we were talking about machine learning. You could do a lot of things too, like get dummies is a good way to generate or convert categorical data into numbers. So kind of with the questions going around before, if we want to take something like, I don't know, we'll take a series of values, A, B, C, D, A. All right, let me see how many parentheses I got here. So you could do something like this. I just gave it a list, A, B, C, D, A, A, A. So those are obviously just kind of generic characters right there, but if they were real categorical data, this is a way of taking that categorical data and converting it into something that you could do calculations on. So this is how, if you have a lot of categories, you could do things like measure the binary distance of, all your records and see which ones are close to one another, do clustering or any kind of distance measurements that way as an option. So this is why this is a really popular tool and works well with things like scikit-learn and sciti and all the other numeric libraries that are out there. So that's it for the demo. There is a ton more that Pandas can do that I cannot touch on within a 5-minute demo. But if you want to learn more, a couple things you could do. Number one, contribute, and you can do that as mentioned at the start. Thank you. we will be hosting a documentation sprint here on March 10th from 10 a.m. to 4 p.m. So ideally, if you have any kind of experience with restructured text in Git, it'd be a great way to get involved. We'll be looking at the doc strings essentially within a couple modules, and we'll actually be making those contributions and putting in pull requests to the Pandas maintainers at the end of it. So, if you haven't contributed before and you want to get involved, it's a great way to start. Or if you're seasoned and just want to help out another project, please come by to the documentation sprint. Plenty of good resources for you to explore out there. The online documentation, even though we're going to be updating it in the sprint because it needs a little help, is still very good and a great resource to start with. Python for Data Analysis is a book written by the guy that actually created Pandas. His name is Wes McKinney. And he's involved in a lot of the big analytics projects you see nowadays. And the source code is on GitHub, so you could always just take a look at that and kind of get a feel for how the library works. Last but not least, contact me. My contact information is here. I'd be happy to help anybody with questions. Again, especially if you want to get involved in contributing, I can help out with that. Or even if you just have usage questions on how to optimize your reporting and analytics, I can help you with that with Pandas. Questions? Yeah.
How does Pandas compare with Matplotlib? Because I noticed that there's a lot of functionality and kind of overlap.
Yeah. Yeah. Okay. So the question was, how does Pandas compare with Matplotlib?
Yeah.
Essentially, right?
Do you end up having to use Matplotlib directly for the stuff that Pandas doesn't do with wrapping?
So I'll say from my experience, there's a lot of stuff like I don't have Matplotlib installed to show you, but you can do like simple like plotting things. Like if you have a data frame, a lot of the data frames have a plotting function, so you can just say like df plot and what kind. Like I want a box plot, a bar chart, whatever. And depending on the type of visualization that you're trying to generate, you may just need to specify like what columns to look at, things like that. But it does have an interface to Matplotlib. I mean, they work in tandem. It's obviously not trying to replace any kind of graphing that Matplotlib does. It really just offers like an interface to it. I still have, and it's probably from my lack of understanding with Matplotlib, is in the past when I've created visualizations, I find that I do still work like in that Matplotlib, a little more deeply than I'd like to. So it's not, I'm not going to say it's like really easy to just generate the plots you want, but it's got that interface where you can either pass a data frame or a series to it or extract the values out of that really easily and then do the Matplotlib stuff that you would do normally. Yeah. I would also say, too, one of the other packages that I mentioned, if you've never looked at it before, is Seaborn. So Seaborn also sits right on top of Matplotlib, but I think it does some things visually that are really nice that help, bridge the gap a little bit between Pandas and Matplotlib, and also just generate better looking plots than what you get by default at Matplotlib. Because if you've used something like ggplot2 before, unfortunately Matplotlib lags behind some of the other visualization software that's out there. Other questions? Yeah.
I use NumPy for machine learning stuff. How does it compare to? It's the same thing as Pandas, and where's on top of Pandas?
So Pandas uses NumPy for a lot of its internal structures that it builds. So, I think you could use either, but where it really comes into play is like it allows you to, when it has a couple more robust data types. So you can, there's a categorical D type that you can work with. In terms of time series analysis, it's really good for like resampling, filling in missing data. Like it's just a lot easier to do that in Pandas than NumPy. And also when it comes to just, creating a structure that has column names and like index names, really in NumPy you're just working with dimensions. So by having the index names and the column names in Pandas, it just makes that a little bit easier. But if you're comfortable in NumPy and get a lot out of that, it's really what the internals of Pandas is built on top of. So you're not going to necessarily get better performance moving from a NumPy array to a series if you're using some algorithms that need a NumPy array. Cool. Thanks, everybody.